Here's our video on GCF. Learning target for today's video is learners can find the greatest factor that two or more numbers share. So GCF, greatest common factor. That's just how we're going to write it, GCF, so we don't have to write out all those words all the time. Make sure you title your page, greatest common factor. Make sure you write down the learning target. And I'm going to move on to our next page. Okay, we have one definition today. We have the definition of relatively prime. And relatively prime means that two or more numbers whose GCF is 1. So they don't have to be prime numbers, but their GCF, or the greatest number they have in common, is 1. So an example would be like 4 and 6. 4 and 6 are relatively prime. They have nothing in common except for 1. Okay, but neither of those are prime numbers, so they're called relatively prime. Compared to each other, the only thing they have in common is 1, and that's what relatively prime is. Okay, so make sure you write down that definition, and I'm going to go on to our first example. Our first example, we're going to use the listing method. So I'm going to show you two methods, and you can decide which method. The listing method is nice for smaller numbers. The other method is nice for larger numbers and works pretty much all the time. This one might not necessarily be the best method all the time. Okay, so the listing method is the first thing I'm going to do is I'm going to find the factors of each number. So 16 is 1 times 16, 2 times 8, 4 times 4. So those are my factors of 16. Then I'm going to do the same thing for 28. 28 is 1 times 28, 2 times 14, 4 times 7. They have no other no other factors in 28. Now I'm going to look to see what the greatest common factor is. So I'm going to look to see what their common factors are. The factors they have in common are 1, 2, 4, and that's it. So those are the three common factors that they have. What's the greatest common factor? Well, 4 is the greatest number that they have in common. So the greatest common factor of 16 and 28 would be 4. That's the greatest number that they have in common. Okay? So I'm going to move on to example B here. So for 12, I'm going to do the same thing. 12 is 1 times 12, 2 times 6, 3 times 4. 25 is 1 times 25, and 5 times 5. So I'm going to find the numbers they have in common. They have a 1 in common, nothing else in common. So the GCF of 12 and 25 is 1. When the GCF is 1, what do we call them? These are relatively prime. Okay, so here's an example of two numbers that are not prime. 12 and 25 are not prime, but because their GCF is 1, they are relatively prime. That's the greatest number that they have in common. So that one has you do all the factors, listing them out, and then looking and searching, comparing the two to find the greatest one that they have in common. Okay? That's the end of example 1. So if you need to pause, go ahead. Otherwise, I'll be moving on to the next screen. In example 2, we're going to use prime factorization. For prime factorization, I want you guys to use your chart. This is why we spent that one day doing all those prime factorizations. So look on your chart for the prime factorization of each number. If you don't have it, you could always do a quick factor tree to figure them out again. Okay, so for 40, I'm just going to list out my numbers that they have in my prime factorization for 40. Remember, 40 was 2 times 2 times 2 times 5. 60 is 2 times 2 times 3 times 5. Now, I'm not looking for the greatest number they have in common like I did in the listing method, because I've broken these down into prime numbers. What I am going to do is I'm going to look for numbers that they have in common. So I'm going to circle a pair of numbers that they both have. They have a 2. Okay, they have a 2 in common. So what I'm going to do is that's going to turn into 1, 2. Then they have another 2 in common. So that is going to turn into another 2. Okay, and then they have a 5 in common. And that's going to turn into a 5. So they have a 2 in common, they have a second 2 in common, and they have a 5 in common. Notice that I'm not writing down 4 2s and 2 5s, because that's what I circled. A pair means that's what they have in common. They have a 2 in common. They have a second 2 in common. That's 2 2s. And they have a 5 in common. That's 1 5. You multiply those numbers. 2 times 2 is 4. Times 5 is 20. So your GCF of 40 and 60 is 20. Okay, I'm going to do the same thing with 28. So 28, I look at my chart, is 2 times 2 times 7. I look at my chart for 45, and 45 is 3 times 3 times 5. I look and I say, oh, they don't have anything in common. There's nothing to circle. These are 2 and 7. That's 3, 3, and 5. Nothing in common. Well, they do. Remember, what goes into every number, and the number we don't use in prime factorization is 1. Remember, 1 goes into every number. So this is not they don't have a greatest common factor. Here's an example where the greatest common factor is equal to 1, which again makes them relatively prime. Okay, so when you do this and there's nothing to circle, your GCF is 1. Okay, that's it for the video. Have a great night, and I will see you guys later.